Yeah. You want me to just jump into it? Yeah, go ahead. All right, sweet. Hello, everybody. Welcome to the AWS, the Hampton Roads AWS user group. Kicking it. I'm so excited to be here and to kick it off for like essentially like a brand new season, right? And so you may be wondering, well, what are we going to talk about today? Well, I'm going to do AWS minus AWS, sort of like a solutions architect descent into existential dread. YOLO, everybody. My name, again, is Paul Chin Jr. You can find me on the socials at Paul Chin Jr. everywhere, the LinkedIn, the Twitter. I work for Serverless Guru. Serverless Guru, we are experts in adopting and helping clients build out serverless systems. We're the best in the world. We're a boutique dev shop. So if you need help with serverless, give us a call. If you want to come work with us, give us a call. Either one of those would be great. I also run Norfolk.js. It's a local JavaScript user group that meets the last Monday of every month in downtown Norfolk at Assembly. We've had all kinds of different presentations this year, and it's a really awesome place. A lot of stuff that I do is JavaScript. I don't know how many of y'all use JavaScript regularly. Couple. Okay, cool. And then, of course, hashtag praise Cage. When I'm not talking about cloud or serverless, I'm a prophet for the one true God of the internet, Nicolas Cage. So where are we going to head now? So right now, I've been doing cloud now for like 9 years, and it's really getting to me. I'm having like a midlife crisis about cloud. So at this moment, I really had to like check in with myself, and I'm hoping everybody else here is going to check in with themselves as well. Like, are we okay? We're going to talk about 4 things. First, the cloud. It's pretty good, right? And then the void. It's pretty bad. And then alternatives. What else could we do? If not for AWS, then what else? And then finally, the kind of big point I want to make is that we're just cloud programmers now. Don't care what your language is. Eventually, you got to put stuff out on a server somewhere. And I claim that we are now cloud programmers, and it's a different way to look at distributed systems. The omnipresent companion, that's AWS, right? It's just hanging out all the time, lurking in the background whenever we got to do stuff. It has everything. Why would you go anywhere else? AWS is the largest platform. They've got like a third of the market share. Azure's coming in at like a quarter, although they are growing faster, but they have a smaller, target to get over initially. And then Google's somewhere in the third in like 12 or 13%. And then everybody else creates a cloud for whatever their legacy niche system is. It's like the IBM Cognos Analytics database as a cloud, right? Like it's all of those legacy clouds. But AWS is pretty good, right? Like we use it, we're here. This is an AWS group. They really did come up with some cool, innovative hosting techniques, right? S3 and then functions as a service. And what always gets me is like AWS as a company, they are really customer obsessed. Like when they say customer obsessed, they mean it. If they think they can build a service and sell it to like one person, they'll build it and then figure out how to sell it to many more people. Who's familiar with AWS Ground Tower? Never heard of it? It's where you can get a satellite. Like if you want a satellite uplink, AWS will sell you a satellite uplink. It's a service. It's a legit service that you can get from them. And it's even better when AWS can take an open source project, wrap a managed service around it, and sell it back to you, right? RIP OpenSearch or Elasticsearch, right? They done did them dirty, I tell you. But that's the world we're in right now. So I made that comic, right? And whenever I find myself up against a behemoth, like an eventuality, like it's inevitable that I have to deploy a service, and it's inevitable that I've got to do it on AWS. That makes me back up and go, whoa. What are we doing here? Is this really the best? Like, do we just have this default method? Like, I do serverless. I love serverless. I do it all day, every day. I reach for that first. But if it's the default, like, what else is out there? When can we take a step back and figure out what's left, right? That's the thing about cloud numbness. Like I'm just like, oh yeah, AWS. Okay, there's another thing and another thing and another thing. And that brings me to Garfield minus Garfield. Have y'all seen this before? It's a comic strip that exposes the absolute anxiety of a man named John Arbuckle talking to nothing. And that's how I feel solution architecting is sometimes, because our clients, the end users, they don't care if it's an S3 bucket, they don't care how many containers you have or how many clusters you've got. They just want their dashboard. They want their inventory system, right? And so we, as cloud operators, are just left by ourselves in a room talking to nothing that is AWS. And so just to see how unhinged this is, right? When you take Garfield out, when you put him back in, it's like, oh, okay, it's kind of funny. But when you take him out, it's just completely deranged. That's cloud architecture for you, right? And so that brings us to sort of like the good things about AWS, right? They do innovate. What else is great about managed services? Who uses the word undifferentiated heavy lifting every day when talking to clients? I do. I've been in the cloud adoption business now, and it's always like, hey, why are you like manually updating operating systems? Why are you manually installing drivers or putting together dependency packages or whatever? Let the cloud do that, right? That's where you can save time, you save headache, undifferentiated heavy lifting. AWS is really famous for saying that like their gains are on other people's margins, right? They're gonna come in and take that little extra 0.1% out of the process and sell it back to the customer by giving them a particular experience or a particular software abstraction. And then the serverless story has been good for a lot of folks. It's really designed to maximize the undifferentiated work done by AWS. Anybody now with a credit card, and that's the important distinction, you got to plunk down a credit card, you sign up for an AWS account, and now you can have truly global scale distributed services with like a couple lines of configuration. It's absolutely insane when you think about it, right? Like maybe 20 years ago, you'd still have to have a requisition form. You'd have to set up your leases. You're looking at a lot more low-level hardware decisions that developers just had to make. And AWS came in and did away with all of that. Right, and so the serverless story has been good. There's a couple of standout services that I use all the time. The combination of S3, API Gateway, Lambda, DynamoDB, and then the obligatory like CloudFront and networking stuff that's all kind of wrapped in together. And over time, I've really come to enjoy the AWS programming model, right? Like I don't reach for, I don't have to go and try to find some web framework because AWS kind of is the web framework. I think about the cloud and AWS as sort of like this fantasy console, right? I can build whatever kind of system I want from their primitives. And I don't have to do a whole lot of heavy provisioning. I basically use the same SDK that's bundled in throughout their entire networking layer, and I just call a new service. I just new up a new service, and it's really nice. But then I have to tell you all about the Kafka nightmare. Now, who's Kafka'd? Nobody? Do we know what that is yet? Okay, so Kafka is a distributed messaging service, right? It has message buses, and you put messages on it, and you subscribe to it, and you pull messages off of it. Cool. The irony, I don't know why the guy decided to name it Kafka. I looked it up on Wiki, and it was like he really liked the writings of Franz Kafka, and it was a service all about writing messages. But like Kafkaesque is also a word, and it's because Kafka wrote nothing but dystopian nightmares about bureaucracy. It was all of Kafka's writings are about a person trapped in a system they can't change, doing things to them, and eventually just failing altogether. So when you talk about something being a Kafkaesque nightmare, like that's what comes up. You're stuck in an infinite bureaucracy. And when I had to implement Kafka once, I was there. Like it was not lost on me. The situation was that I was, happily building my system for the client, and they had a third-party system that I had to integrate with, right? Like I had to stand it up and like kick off messages to it through this Kafka thing. And it was this huge bundle of applications running in Kubernetes. And the client came to us and they were like, well, you're good at cloud. Like you can just take this and do it for us. And I was like, whoa, hold on now. Like I kind of stop at, Kubernetes orchestration workflows. Like that's not where we particularly shine. But, I said, well, we're going to give it our best shot, right? And eventually, I figured out EKS, I figured out Terraform, I figured out how to get all these Java applications running. I was shocked because it took 25 minutes to start the whole thing. Like when you say like go and Kubernetes starts building its clusters, it was like almost a half hour later before the application was up and running. And in order to debug it, what I ended up doing was building my own like node container and shoving it in as like a little sidecar so that I could have some kind of interface with it, since I can't write Java, but I can write Node. And eventually I figured it all out. And then maybe like 2 or 3 months later, the client was like, yeah, this is okay, but like we still need more messaging. And I said, well, that's cool. I can just set up an event bridge system. Has anybody used Event Bridge yet? Yeah, it's really cool. So we have our APIs, they're running, and instead of generating all of this extra infrastructure in my SDK and in my infrastructure code, I jump onto the native Event Bridge that's just part of the account anyway. I standardize my little JSON event object and subscribe and done. Like, a week, we have a full message bus ready to go. Like I'm not messing around with lots and lots of complicated systems, right? And so that's the good thing, right? Those are good things that the cloud can bring us. Then there's bad things. There's lots of bad things the cloud can bring us. Now we're just feeling the void. Now we're waking up and Garfield's still napping. We're just by ourselves. Nothing's perfect, right? Like it's fine. It's fine. When you're ready to adopt cloud, and we help dozens and dozens of clients to go through this, it's not a silver bullet. You still have to really understand your requirements, because all of these managed services, the unspoken rule is all of their service quotas and service limits, right? So what you're giving up in sort of the trade-off for doing all these things low-level, manually setting up Kafka queues and just using Event Bridge, is because Event Bridge, the event you put on it, I think has a maximum size of like 256 kilobytes. So you're good until that event object becomes too big for the service to handle. And then also, I think you only get 100 buses per region per account. So, that should be enough. And, if it's not, then you have to go through, find another system. But that's kind of the caveat with every single managed service. Like there are service limits, because if you think about it from the provider side, they have to create an entire control plane for you as an abstraction. So they are now operating with their resources and they chunk them out for you. So they're going to have service limits. To AWS's credit, over time, they increase those limits. They make stuff faster, they make stuff a little cheaper. If you're on an enterprise account, you get shockingly good support. Like you can use the support console, write a little message, and like a TAM will get back to you, and their customer support will run down whatever issue you're having. And they do a really good job of like getting into it, because they can see so much more behind the scenes. And when we're dealing with new services, we will try out a lot of the stuff before it goes GA. And through that customer support, we're able to give feedback and get the APIs changed one specific example was when I think it was Redshift was going serverless, and they had that API changed a lot while it was being developed, and we gave a lot of feedback to them about it. But once it goes GA, AWS does a really good job of keeping their API stable and keeping their SDK contracts pretty much locked in. The times that I have to go and look for Terraform modules, there is nothing standard about any of that. In Terraform land, I was looking, and there's an Nginx ingress module and an ingress Nginx module, and they were two totally different things. And it's just madness. I thought that the JavaScript ecosystem was fragmented, and then I started playing with Terraform, and I was like, this is insane. There's too much variability, and of course, terrible billing. AWS has you'll never know if you're going to get surprise charges, right? So they'll give you the fastest, biggest, baddest infrastructure with just a little credit card, but the flip side of that is you can create a giant old cluster, run some machine learning inference on it, and it's like $50 an hour, and you never know until you actually try it. And AWS doesn't have any incentive to make it harder for you to spend money. If anything, they want you to spend as much money as possible, as easy as possible. And then as a negative, I don't know if it's a negative, but I definitely want to mention it because for people that are just starting into AWS and trying to really understand all of its intricacies, IAM is a big thing to kind of take on. How you set up your organizations, how you set up all your roles, your policies, your users, both human and non-human, right? They all are run through IAM, and it's confusing, and it's a lot. It's a lot to set up. Thankfully, most of it is upfront. So when you first build the system, you hopefully will have all of those account controls in place, and you don't have to change them very often later on. But it's still a big thing to think about when you're going into AWS Cloud. So what does an app really need? I'm coming at this from the perspective of a web developer, somebody that's got to stand up web services day in and day out. So what do I really need? I need something that's going to have static assets that I can serve from, some client-side code that I can serve. I need some kind of server-side processing compute. I need server-side entry points, so that's like an API gateway or some other kind of load balancer in front. I need a persistent data store. I think most modern applications that I'm dealing with now don't just have one database. They've got multiples, multiple types of databases depending on the workload that's happening. And then there's always DNS, the networking layer. I try to stay as far away from that as possible. I try to get in and out, Route 53, the DNS, the caching layer, all of that stuff. And then I think the biggest differentiator now for cloud programmers, what I'm saying, we are cloud programmers, is tied around automated deployments. I think that the big differentiator for someone who's going to take full advantage of distributed computing is going to be able to have a system that is version controlled and has a nice CI/CD story, and you can do all of your tests and deployments directly through version control. And AWS, they give you some tools. They've created SAM, that little squirrel thing. That's AWS SAM. It is a framework application model where instead of writing hundreds of lines of CloudFormation, you're writing a more concise SAM template that then gets compiled into CloudFormation and deploys it for you. There's Amplify, which is sort of like a front-end framework that gives you a CLI for all the different AWS services. So you could use GraphQL, or you could use a database, you can do static hosting, and that's all through Amplify. CloudFormation is the base infrastructure as code primitive. If you want to write very specific directions for what you want to deploy as a resource in AWS, you're going to use CloudFormation. And then the new CDK is really popular. It allows you to program in different languages like TypeScript, JavaScript, Python. I think there's a C# one. I think there's a Java one. But basically, the CDK stands for Cloud Development Kit, I think, and it lets you programmatically create resources. Has anybody actually played with CDK? Yeah, do you like it?
It's okay. It's better than CloudFormation.
Yep, it's better than CloudFormation because you can program it, right? Like you create higher level constructs that you can essentially build your own type of custom primitives that you can call to inform AWS of what to provision for you. So those are all the things that an app needs. And we've talked about how AWS is pretty good, how it's pretty bad. But when I go to evaluate alternatives or see what else is out there, it's these types of requirements that I have in the back of my mind, right? Like, is there static hosting? Do I have some compute? Do I have some kind of database? Is there any kind of deployment plan, right? Last thing I want to do is just like go and create a VM and then shell into it. I always joke, like, if I have to actually like SSH into something, I've messed up. Like, I've messed up terribly. Like, I should never have to go into a machine. So that brings me to stacks on stacks on stacks on stacks, right? It's turtles all the way down. Computer science, fundamentals, abstraction layers. This image here is for the Disney multiplane camera. Are y'all familiar with that? Ever heard of it? Okay, so it's Bambi time, right? It's like the 1950s. And when you watched the Bambi movie, it actually creates parallax, like it's cinematic. That's what was blowing people's minds about these cartoons, is that the camera would move and things in the foreground moved faster than things in the background, right? It creates the illusion of depth. Well, what they did was they built this humongous, like it would reach up to the ceiling, and then they'd have plates in between to create layers of depth, and they would shoot a camera straight through and optically composite it. So you'd have all these engineers sliding in and out plates and shooting it and animating it, and they invented the multiplane camera. And I thought this was a really good sort of analogy for the abstractions that we're looking at now. And I think infrastructure as code, it's been around forever, right? Like the idea of describing the state of resources that you're going to use to compute on. But it really is the key abstraction that allows us to grow beyond AWS, beyond the cloud that we know it today. Because it's declarative, right? If I say I need a bucket, I'm going to get a bucket. It's deterministic. If I have a series of resources that my service needs, if it's in infrastructure as code, every time I push a change, it's going to be the same stack over and over again. And you can even inspect, the CloudFormation stacks to see exactly what the inputs and outputs are. And I think that it's a really nice superpower to have, and it's no longer just like a folder of bash scripts that have to run one after the other. It's ephemeral. It's really powerful for a developer to have ephemeral assets behind them and resources, because they can have their own development environment that's going to match production environment. And it's exactly the same resources. And you can tear them down and spin them back up just the same every single time. And because of that, now we can really look at AWS minus AWS. Like what else is out there? Here, look, I made myself look important with like a really cool looking quote, and I think it uses good words. It's like ISC, infrastructure as code. First of all, like, does everybody understand what I mean by infrastructure as code? Like, it's a awesome, huge topic. It enables a spectrum of possibilities, and it allows the developers, you, to really choose a cloud compiler that best suits your need, right? Now we're thinking beyond just virtual machines and containers. Now we're thinking about like that fantasy console, right? Like in your mind, like when you're building a system, I need a queue, great. I need some compute, great. I need a durable store here. What kind of durable store? Key value, well, wide column, whatever you want. Like you can kind of build it out in your mind and then write the program for it using different tools. And then earlier I showed you, those are all the kind of CDK, SAM, CloudFormation, those are all first-party tools from AWS. And they have different levels of complexity and nuance and esotericism, but they still require you to have an AWS account, plunk down a credit card, and understand all of those other things. IAM, like it doesn't relieve you of that burden of understanding what AWS is. So where could we have a cloud that would remove that burden of understanding what AWS is, right? What are you actually solving for? I get salty about dashboards because like I do them all. Yeah, you know what I'm talking about. Babe, are you okay? You barely touched the dashboard you claimed was mission critical. So there's all kinds of services we're building. We're being asked to build content sites, dashboards, brochureware, CRUD apps, dashboards, ETL pipelines. Now we got machine learning inference endpoints, distributed messaging, cron tasks, transactional data and analytical data. Those are two totally different workloads. And then more dashboards. All they want is a single pane of glass. They want to see the hockey stick go up. So could we really build a cloud for everyone based on all of the nice stuff that AWS has already built? We sure can. And so now we're going to get into the plethora of alternatives and services out there and kind of give you an idea of what you can do to evaluate them, how you can use them. So for front-end developers, it kind of all started with Netlify. They came up with the idea of the Jamstack. It's sort of like JavaScript. It's just a very front-end heavy application model. You have everything hosted in a static bucket. You have a static build process. And then if you need any kind of dynamic information, you just call a third-party API. It's not really something that you control. You're just making fetches and getting data. Netlify itself is a service, right? Have y'all heard of both Netlify and Vercel? Neither of those? Okay, so these are very much tailored for front-end developers. So the folks that are dealing with mostly like content sites and static site generation. Netlify is an awesome option. And let's see, in here, let me see if I can click on this. If it'll work. Yeah. So Netlify has changed a lot over the years, but the big thing that I want to point out is that it brought the cloud programming model to front-end developers. Like they made the process of pushing code to Git repository, and then Netlify picks it up, deploys it, and it's like live. It was a really big sea change for front-end developers, because now not only could they just work on their own local environments, now they could deploy directly to the cloud. And they've got all kinds of services to be able to handle the caching layer and handle like image optimization at the edge. And they even have serverless functions, which are Lambda functions, right? Like, so everything here is built on top of AWS. So here, you get a Netlify account. You don't have to put down a credit card. You get the free tier. They essentially give you like the free tier of AWS. And there are still service limits. But now, you get Lambda functions without ever having to write CloudFormation, without ever having to create an AWS account. And you get that nice, request response model on that handler. And Netlify, their latest thing, they actually have these things called edge functions, which are distributed compute closer to your user, and it runs the Deno runtime because they can create these cloud isolates quicker on edge applications, and that's pretty neat. I think that's pretty neat. Right. So, and then Vercel. Vercel is a very interesting platform. It's also built on top of AWS. They also give you serverless functions. It's the joke about Vercel that I make is like during stand-up, it's basically JSConf. Like they hired all of the top JavaScript open source talent. So all of the front-end frameworks, Astro, Next, Svelte, like they're all now housed under Vercel. Like they are putting a ton of engineering dollars and resources into maintaining this huge front-end ecosystem, and they want to be the hosting platform for JavaScript apps. The tools are super impressive since they have a lot of really like specific vision for like JavaScript SDKs. They're able to knock them out really quickly. If you want to like spin up a SaaS really fast, this is a good way to do it right on Vercel. Early last month, there was a local hackathon, and we took second. Yay! Like we won second. Jeff was there. Jeff was on my team. Like, yeah, we did it. And we did it with Vercel, right? Like we were like there was like 12 groups, and we came in second, and like it's all because like I could just build really fast on Vercel. It has everything you need, and it's still AWS. Without AWS, you don't need an AWS account. You still get access to Lambdas. And Vercel's even built like a key value database that you can hook into. And one of the impressive tooling comes because like it was, of course, it was like AI. Everything's AI driven, but they have like an SDK that's pretty much just like drop in ChatGPT, like with the whole interface and everything. They've componentized it all. So you get that streaming response, and it just looks really nice. And they provide it all. Now, we're going to talk about stuff that's even fuller stack, right? On this side, we have Begin. And Begin.com is a deployment platform for serverless apps. And they do that with their open source framework called Architect. And Architect is like, it's like an all-in-one web app, like utility knife, right? And when you use it, it gives you a really great local development environment. So you're able to, it's got like a DynamoDB simulator and an API gateway simulator. It'll also simulate WebSockets locally. And over the last year or so, they've also introduced this thing called Enhance, which is their front-end component web framework that just takes in HTML and is compatible with proper web components. So it's sort of like the anti-React stack, if you will. I think that they've got the best local developer experience. Like SAM has some, Serverless Framework has some, but I think theirs is the best. And definitely go check it out. Again, and it is a direct abstraction for AWS. So when Architect was created, it was created because they were doing serverless apps, and there wasn't a framework out to kind of handle service discovery. Because like one of the most annoying things when you're building cloud services is like remembering like the ARN of the service that you're trying to connect to, right? Whenever you're creating a new queue or a new bucket or whatever, you get that ungodly name. The Architect framework has a service discovery mechanism built into it. So as a developer, you can just sort of write whatever you want to call it, and then behind the scenes, it'll go and fetch and figure out like the machine identification for it. And then there's Amped. Amped is the newest thing. It gives you kind of like a whole new different runtime, but it's still AWS. Where Architect says like, yeah, I'm gonna have a new bucket. The idioms that Architect uses are closer to what you would expect AWS to be, but Amped just like says, nope, like you don't need to know anything about AWS. If you want a function, you just say new function. You don't have to specify the Lambda and the Lambda config and all that. It handles everything for you. And it's a brand new service. And it's part of this movement, right, of taking this infrastructure as code and using that to be the portable mechanism to be able to wrap more and more abstractions on top of the existing AWS services. And AMPT itself likes to call it infrastructure from code. Like when you go and, let's see if I can do this. When you go to look at it, after you install the CLI, you basically import their SDK, and then it will compile out your code to CloudFormation and deploy everything for you through their dashboard. And so, like, it's really cool to play with because they even give you like a really nice WebSocket interface. Architect does too. Architect also has WebSocket interface and a DynamoDB client. AMPT also has a storage, the idea of this like storage client and a data module to be able to just use Dynamo without actually using Dynamo directly, right? And these services are an example of these higher level abstractions that people are building on top of AWS. So that's like kind of the fuller stack model, right? We've started at the front end. We go a little fuller stack. We go beyond the container. We're talking about cloud programming, building the cloud of our dreams. And then you can get even more wild. You could write a whole new language, right? Like, see, the guy who made CDK, he was like, oh, this is cool. We can use JavaScript to create cloud resources. But what if we made a whole new language to create cloud resources? And that's what WingLang is. I haven't tried their cloud model yet because it's like you can't sign up for it. Right now it says like book a demo, but I'm sure it's like a nice deploy service where you can hook up a Git repo and get analytics, do team stuff and all of that. But the WingLang itself, it's a brand new language. I like showing these things because now the difference here is you do deploy to AWS with WingLang. Like you do specify AWS credentials. So it's not as clean of an, it's not like Begin and AMPT where you don't need an AWS account. If you're going to use WingLang currently right now with the open source project, you're going to need an AWS account. But in this language, basically, they have this concept of pre-flight and in-flight, which I think is really interesting because it logically splits up your code base into like two phases, pre-flight. So those are all the things that they have to build at compile time. They take your code and they figure out how many functions you need, how many queues you need, how many database tables you need, and they'll run that. And then the application code of it is run asynchronously in line as part of the in-flight model. So that's your runtime code. So WingLang itself is a brand new language that they've created to be able to do both like compile time resources and then runtime code all at the same time. It's pretty wild. I'm definitely going to be keeping my eye on it because it basically brings like the OOP style constructs to cloud primitives themselves. And I think their goal is to be able to have it go across clouds eventually, like more than just AWS. And then there's Deno. Deno is a new JavaScript runtime built by the guy who made Node. So he made Node and he was like, I could do it again. And then he wrote Deno. And Deno is interesting to me because he learned from creating Node that you can get a lot more VC money if you build your own cloud. And so now, like Deno has its own Deno deploy its own Deno deploy service. So I will write a Deno app, like a Node app, and then deploy it on Deno Cloud. And it feels very serverless, but it also feels low level at the same time, but only if you need the low level stuff. Like you could write a more specific like API gateway type interface, but you don't have to. But if you wanted to, you could. And it also has a key value store. The thing that I'm always on the lookout for are serverless databases. Like we need more databases that can scale up, scale down, and don't require a socket interface. I want it to just be an HTTP interface, something that I can just hit with a web request and not have to deal with like socket negotiation and connection pooling and all that stuff. I think there's still plenty of room in the market for better and better database models. And so that's why I try them all out, right? Like DenoKV is really cool because it's built into the runtime. It's actually got an in-memory kind of Redis type system built into the Deno runtime. And then also the newest thing that they're doing is they're promoting the fact of like sub-hosting and this idea of cloud isolates, which is why Cloudflare uses them on the edge, and Netlify also uses them on the edge. So the Deno runtime you can actually box up and use super quickly, and it's super lightweight, and it has a very sane permission model where the code gets executed and you can really sandbox it. So the argument for Deno subhosting is if your application sort of accepts user code, like imagine you were building a cloud IDE for whatever reason, or your users are gonna have executable code that you need to evaluate, you throw it in a Deno isolate, and then that way it's sandboxed, but it's still like you still can play with it and network it into your application, but you know it's going to be safe and separated. I think that's a really cool model to have ready to go. Bonus round. So these are two things that are probably the most fun from the hackathon that I mentioned earlier. I use Streamlit to do all of my machine learning stuff. If you write a Python script, you can use Streamlit, and it basically wraps your Python script in a web server and UI components. And it'll let you build out a full-on web app with data visualization. And it's hosted on their cloud. It's really nice. You just write your code, and when you check it in, it goes deployed, and you can check it out live. But it is really tightly coupled, right? Like you're not going to be using Streamlit to create an API service because it doesn't have that mechanism. You don't get to interact with its web server in any way. And then there's ValTown. I love ValTown. All right, this is seriously future stuff. ValTown, if you haven't checked it out. So, you know what a GitHub gist is, right? Like gist, you put little chunks of code. Well, ValTown takes the idea of a gist and then lets it be executable. So every script that you write gets an endpoint. And like, it's so much fun. So basically, oh, you know what? Let's go to ValTown. And it's like 3 people that are building this. Val.town, yep. Yeah, so check this out, right? Like this script here is just on its own, and it has a little like a social networking aspect to it. So you can have a collection of scripts, and you can include other people's scripts in your script, and they'll just run like Lambda functions, and like you don't need a AWS account. I'm not actually sure what they're doing behind the scenes. They're like, I have no idea how this thing is actually working, but it's like magic. So if you have like an iPhone, Apple has this like shortcuts feature where you can create your own little drag and drop automations for your phone. And one powerful thing that I like to do is like use webhooks, right? Like the automation will then send a post request to some endpoint. I write all my post endpoints with ValTown. It's a really strong programming model. I really love it just to like, because you know sometimes I want to have I want to have an endpoint that just like, I don't know, returns me some calculated JSON or whatever, right? And if I'm going to do it on AWS, I got to have an AWS account. I got to pick a framework. I got to write all the infrastructure as code. Then I got to deploy it, and I got to maintain it. Instead, I just write code directly into this thing, and it just executes. And it's got a cron model that's really cool. It's got an email service, and like it is super cool. I think this thing is gonna, like, I think this is really gonna take off. It's the most fun to use too. I guess at this point, does anybody have any questions about like this list of services that I've kind of gone through? I know it's a lot. Like there's a lot of other stuff that I didn't want to include because it's things like Pulumi or Terraform itself, right? Those are more infrastructure as code tools and not explicitly like extra managed services on top of AWS. So that brings me to my final point, which was that we are now cloud programmers, right? I think of myself not as a JavaScript programmer anymore because now I'm also doing Python and I'm doing JavaScript. And I can take apart a Java app if I really need to, or I can inspect, a .NET app in C# if I need to. But ultimately, most of my time and my day is spent like, how do I get this stuff into the cloud? And how do I operate it with like the least amount of headaches? So are we cloud native or cloud naive? I don't know. These are the big brain thoughts that I wanted y'all to come away with, right? Everything's going to be distributed. For most cases, I think there will always be some edge case where you have to go low level, where you have to specify how much memory you have. You have to specify how many threads you need because you're doing, high performance compute calculations on quantum physics models or something like that. But if you just need to like look in a database and like bring back a JSON, most of the time, like API gateway will be fine. So everything's going to be distributed, and I think HTTP is a really great fundamental protocol. Client server fundamentals are never going to go away. I actually teach my kids, like whenever they come up to me and they're like, my iPad's not broken. I was like, all right, let's inspect the network tab. Like, let's figure out like what's going on. And they even understand like, oh, the internet is just some computer far away that it connects to and, sends messages and data back to them. Who's familiar with like 12-factor app? Yeah, cool. So the 12-factor app methodology was put out by the wonderful people at Heroku. And Heroku is like the grandfather PaaS platform. They made this idea of like, just deploy it and like, it will take care of everything else. That really depends on these stateless runtimes. And that's exactly what a Lambda function is, right? And that's what EKS really is. Like they're these stateless runtimes. They have sort of a declared state or a declared resource that's got to be there. And then it does the computation, but then in between processing, like it doesn't know what happened before or after. It's just a completely stateless runtime. The other thing that's important, of course, is the infrastructure being deterministic. And I wanted to finish it up with, more Garfield jokes. Multi-cloud Mondays. I like to call them multi-cloud Mondays whenever somebody's like, maybe we should go multi-cloud. It's the same, like I have like the same like eyebrow furrow that when someone is like, we need to go multi-region. I'm like, okay, well, there's a lot to that, right? And then back to Garfield minus Garfield. In this comic, I love it because we could take Garfield out and it's just John being insane. Or we could take John out and it's just Garfield being run ragged. And that is how I feel as a solutions architect in AWS Cloud. I don't know which one I am sometimes. Lasagna. All right, we did it. Give yourselves a round of applause. That's right. We finished this presentation. So you all get to see this certificate. And it's signed. Does anybody recognize the signature? Andy Jassy. Yeah, I got Andy Jassy to sign it.
Will we get a badge?
I can make badges real quick. I think I can make them. I can make them out of these plates here. So thank you very much. If you have any questions, let me know. I would love to go over it. If you need any cloud counseling, I'm here. My door's always open. You know, the big bad cloud can do some awful things on some days, and just need somebody to talk to at Paul Chin Jr. and serverlessguru.com. Thank you all so much for your time, and that's it. Cool, we did it.